M7 Unit 8, Lesson 3, Part 2, Histograms. In this video, we will be talking about interpreting histograms, being able to read them. So this histogram shows the national distribution of FICO scores, which the FICO scores, they're your credit score. You use it, it kind of says how good you are at paying your bills, basically. It's used to, they look at it when you're getting a loan and that sort of thing. So looking at this, along the x-axis is the FICO score. We've got the numbers between 499, between 500 and 549, between, that should be between 550 and 599, 600 to 649, 650 to 699, all the way up. And by the way, your math teacher's credit score, actually I'm not going to tell you my credit score, never mind. So right here, first question, what's the most common interval class of FICO score? Most common class would be the class that has the most in it, which is definitely this bar, which represents people having a credit score between 750 and 799. Okay. Next question, what percent of the population would qualify for a loan for which you need a FICO score of 700 or greater? Well, here's 700 or greater would be all three of these bars. So this first bar is 18%. This next bar looks like it's about 27.5%. And the last bar looks like 14%. So if we add these together, we would get a percent that we expect to be able to get that loan that we were talking about. So if you need a 700 credit score in order to get a certain loan, there's 59.5% of the population that would be able to get that loan. I guess that means the other 40.5% would not be able to get that loan. Okay, these are the heights of black cherry trees. Along the bottom is the height. What's it measured in? It's measured in feet. And the frequency. So this doesn't include every cherry tree, but it's just a sample of cherry trees. What's the median class for the height of black cherry trees? All right, median class is the place we would find the median. We won't know exactly what the median is, but we can find what class it's in. As we count our way through here, there's 3 in the first bar, 3 in the second bar. The third bar has 8. The fourth bar has 10. The fifth bar has 5, and the last bar looks like it is 2. If we add all that together, 3 and 3 is 6, and 8 is 14, 24, 29, 31. Okay, if there's 31, we do the, where's the median formula? 31 plus 1 over 2. It's going to be the 16th. The 16th data point is the median. So 3 and 3 is 6, plus 8 is 14, 15, 16. It's going to happen somewhere in here. So the median class is 75 to 80 feet. That would be the median class. We don't know what the median is exactly, but we do know that it is between 75 and 80. All right, estimate the mean height of black cherry trees. Now, the reason we estimate it is because, I don't need to erase that. Remember what mean is. You add up all the numbers and divide by the number of numbers. You're trying to find the equal share average. Now the way you would picture this on a histogram is pretend that it is made out of a solid material and you are going to try to balance it. At what point would you assume that this would balance? And I think it would balance about right here. That looks like about a good balance point. And that is about 76. That's estimating the mean just by picturing where it would balance. Okay, based on the given data, what is the probability that a black cherry tree will be between 70 and 75 feet tall. Well, between 70 and 75 feet in the sample, there are 8 black cherry trees in the sample that were between 70 and 75 feet. There were 31 trees total in the sample, so the probability of me picking a cherry tree that is between 70 and 75 feet tall is 8 out of 31, which is about 25.8%. So we expect about 25.8% of cherry trees to be that height. Okay, refer to the student's heights graph. By the way, when you read a graph, start by reading the title of it. Look at the x-axis, it's height measured in inches. The y-axis, number of students. How many students are at least 69 inches tall? Well, here's 69 inches, and taller would be just these last 2 bars. This bar has 30 students in it. This bar has 10 students. So we expect 40 students are at least 69 inches tall. Is it possible to tell the height of the tallest student? Now you might think so, but over here, the tallest 10 students are in the range 72 to 74. Now it is possible that all 10 of them are 72 inches and none of them are 73 or 74. We don't know for sure. So because of that, we cannot tell the height of the tallest students. You cannot tell because all you can tell is what range of values that tallest student is in. Okay, next example. Okay, first when you read a graph, read the title. Top South Carolina cities by population. Look at the x-axis. We've got 0 to 50,000, 50,000, 1 to 100,000, and 100,000, 1 all up to 150,000. And then read the y-axis, frequency. 0, 2, 4, and 6. All right. How many cities in South Carolina have populations less than 150,000? Okay. There's probably a lot more than this, but we'll go with it. This bar has 4, this bar has 4, this bar has 2. That adds up to 10. Okay, no problem. Is it possible to find the median population? All right, we can find the median class, but no, we cannot find the median population. The reason is we only know a range of values for the median. We can't tell what the exact median is, just have a range of values for the median. Okay. All right, this is a little bit of a comparison one. Which event has more winning times less than a minute? All right. So the Olympic women's swimming, 1924 to 2004. We've got 100-meter freestyle and 100-meter backstroke. Now looking at these, which one has more or less than a minute? Well, backstroke has none less than a minute, and freestyle has what, 7 and 2, 9 less than a minute. So based on that, you could actually say that freestyle, they are able to swim faster than the backstroke. Interesting. Okay, that's it for this video. Please watch the next one. Thank you for watching.